Afternoon, everybody. Are you the only guys that care about public cloud security in the whole place? That's cool. Welcome. My name is Russinovich. I'm a technical fellow in Azure. I've been in Azure for about 4 years. And my primary job responsibility is to look at the compute stack from the very bottom, our data center infrastructure, all the way up to our cloud programming model. But as many of you know, I've got a strong interest in cybersecurity, and I have from way back before I joined Azure. And so one of my roles in Azure is also looking at security and cybersecurity of the cloud, thinking about how customers can stay secure and how we can secure customers. And also, I think from me, a very high priority is how we can make sure that our infrastructure is the most secure infrastructure. Because there's one thing about public cloud computing that is very important for Microsoft and any other public cloud provider to keep in mind, and that is there is no cloud without trust. Because we're asking you, customers, to put your data under our control, into our data centers, onto our servers, under our operational management. And that is an enormous responsibility. And you're only going to do that if you trust that we're going to handle it properly, that we're going to make it available to you when you need to access it, that we're going to prevent other people from having access to it. If we screw that up, we can lose your trust, and that means that we can lose the whole business. It's not like you've bought a piece of software from us and you're off and running it and you lose trust in us, but you continue to leverage those services. For this kind of business, we've got to keep and maintain that trust going forward, and security is one of the key pillars of the trust. The other ones, of course, being availability and reliability. So this talk is a talk that I put together because as I've been talking to customers and as I've been talking to even people inside of Microsoft and Azure, a lot of misconceptions around what it means to be secure in the public cloud. A lot of misconceptions about, oh, the cloud is somehow less secure than on-premises environments, or somehow it's a huge risk for me to go and put my stuff in a public cloud because of who knows what's going to happen there. So the purpose of this talk is to dispel some of the myths around it, to get you thinking about how you play a part as you move your data and manage your users accessing the cloud, that it's not just our responsibility, it's not just your responsibility, it's a joint responsibility to secure this data. And then also to talk about some of the risks that we hear you tell us, what you're thinking, CIOs, why they are afraid of moving to the cloud, what makes them hesitant to move to the cloud. Talk about really what is behind those risks. Let's take a look a little bit deeper into analyzing them. And then let's talk about mitigations that you might be able to put into play, or we put into play, to mitigate those kinds of risks. That's the goal of this talk. I'm not going to be doing any demos. It's a very kind of different talk than you might have seen me do, or you're going to see me do tomorrow, which is a down, dirty Windows internals kind of thing. This is a high level, let's get thinking and talking about the architecture of public cloud computing and the threats. And to set this up, this is a very disruptive phase. Brad showed a slide like this, and this is redundant with that, but I've given this talk before internally at Microsoft. I've also gave it at RSA conference, a version of this. And this is obviously the third phase of computing that we're moving into. And whenever it comes to a new phase of computing, a new way of operating computers and managing data, there's questions, there's unknowns. We're all learning. In fact, we're learning. I'm still learning about how to best secure our systems in this particular aspect. And so it's obvious that there's going to be questions. It's natural that there's going to be questions, and we all have to work through this together, and we're going to come up with some new answers as we go along, too. So I'll wrap that back around to the end. The problem here is that, like I've mentioned, the public cloud is built on trust, and security is a key part of trust, and if we screw that up, that's potentially the end of Microsoft's public cloud computing business, or at least a major setback for Microsoft and maybe the entire industry. I think one of the interesting things I saw was that Microsoft and Azure had cloud outages of reasonable size a few years ago, and the press and the public, the technical public, kind of the market, reacted to those things by saying, oh, looks like public cloud computing isn't ready yet. And people start to think, maybe I should back off and wait till this thing becomes a little more mature. So that's why this is so important. And when it comes to considerations for moving to the cloud, security is not the only reason that customers say, I'm hesitant, or I need to take my time, I need to understand things better before I move to the cloud. But security is definitely one of the key considerations. There's study after study that comes out which says, interviewing CIOs and saying, hey, looks like the cloud's coming. What do you think? Are you ready to move to the cloud? And you can see that time after time, they come back and say, well, the cloud looks interesting, we're looking at it, but security is really something that worries me. In fact, here are some of the other things that they worry about. And you can see in this survey from 451 Research back in December of 2012, they rated these various different considerations on a scale of high concern, medium concern, low concern, and you can see, for example, immature technology. Is the cloud immature? Well, some people are concerned that it might be a little immature. And then you can see all the way down to compliance. People are concerned about compliance because of their own businesses and regulations that they've got to operate under. But what I blacked out here is that the number one by far with high concern is security, 69%. How many of you are concerned security moving to the cloud as your number one concern for moving to the cloud? Okay, so let's work together on figuring out what's real, what's not real, and what you can do about it, and what you should be really worried about versus not worried about. So we're going to identify the threats, discuss the risk of each of the threats that people talk about when it comes to security in public cloud, and then we're going to explore some of the mitigations to figure out how we can reduce risk from the levels they might be at, things you can do and things that we're doing. To kind of frame the discussion and make things a little more concrete rather than hand-waving and saying, oh, data loss, that's a threat, is to really talk about what does data loss mean? How can you lose data in a public cloud? I've set up a canonical reference architecture, and it looks like this, that we're going to use various points throughout the presentation to try to make these things a little more real. So first of all, you've got the public cloud infrastructure itself. So this is the public cloud. And you can see that the public cloud consists of a few different components. One is the interfaces that are the public interfaces. These are the management interfaces and the data plane interfaces for customers to go create virtual machines, create email subscription, email accounts, to create mailboxes, to deploy virtual machines and code into those virtual machines, and to access data in the public cloud. Of course, underneath those APIs is actually a virtualized infrastructure. So most public clouds rely on virtualization as a key part of their security and multi-tenancy. Azure is fully virtualized. So you see virtual machines there with hypervisors underneath them, of course, Hyper-V. And then you see storage servers there, and then at the bottom you see racks of servers and disks. You see a DC operations person. So this isn't our giant data centers. You have a few people running around maintaining the data center facility. Then you also have us, Microsoft, the people that are developing the software and operating the software. In this new DevOps world, we've got developers that are pushing code into production and then sometimes debugging code in production. And so some of the teams at Microsoft have separate deployment engineers that are actually responsible for pushing the code that the developers create. So that's represented there. And this part of the infrastructure is operating on the same technologies that your on-premises networks are. This is built on Active Directory, Windows on our desktops, Windows servers, on our domain controllers, the same kind of infrastructures. We're talking through private networks into our data center, so this isn't going over public IP addresses. This is through Microsoft internal backbone that goes into our data centers for us to push code into there. And then finally, we've got, of course, the customers of the cloud, and these include the enterprises. They include consumers that are accessing consumer services that are built on the public cloud. And again, these kinds of services aren't just Microsoft services, but anybody building services here. So if you have an enterprise, for example, you build a line of business app, consumers are going to be going and accessing that line of business app that's running in a public cloud. And then, of course, we've got these guys, which we all hate, of course, the people that are out to screw everybody over, but we've got to deal with them, and these are the attackers. The guys that want into the data, the guys that want to bring down the data center, and they do it for, as we know, many, many reasons, from political motivation to, hey, it's just cool and I'm impressing my friends on ICQ, to whatever. It's a political nation thing, or actually I'm going to steal the data and then sell it. Now, when it came to the threats, me sitting down to talk about this, of course, I have in mind what I consider some threats to cloud security. But I thought, I'm just one person, and really it's you guys, the CIOs, CXOs, the IT administrators, the ones making decisions about what you move to the cloud when, that are really the ones defining threats, what you consider threats. What's an example threat that you imagine when it comes to public cloud in security domain? A threat to your data. What would be a threat to your data? Anybody? No threats? Yeah, one. Foreign nation states, like what is the threat there? Okay, so this is exposure of your data to somebody that you don't want to have access to your data. This is nation state being able to say, hey, I want access to that data. For some reason, you're from Europe, aren't you? Yeah. So this is, I could guess that. That's a big concern there. Anybody else, any other threat to data in the public cloud, to your data or compute? Denial of service, that's another one. Yeah, another one? So diverting traffic, so to someplace else, that's a potential threat. I'll take one more and then virus penetrating the hypervisor security boundary. That's a good one right there. These are all examples of threats that I've also thought about. But instead of just coming up with my own list, I thought it would be interesting to refer to the Cloud Security Alliance. Anybody familiar with the Cloud Security Alliance? So a few people. The Cloud Security Alliance is an organization made up of representatives from a bunch of different companies, including Microsoft, that obviously focuses on cloud security. And one of the things they do is periodically survey their members, as well as CIOs, business decision makers at companies, and say, what are you concerned about when it comes to security in the public cloud? They first started this back in 2010, and they wrote a report called 7 Top Threats to Public Cloud Security. And then they realized, you know what, we missed a couple. So then they wrote a paper called about 9 top threats. They called this the Notorious 9. Has anybody heard of the Notorious 9? So you can go download this as a free download off of the CSA website. It's a PDF. It's actually a pretty terse document, but it does document the 9 threats that they organized as a result of these surveys. And that's what I'm going to go through. Now, the 9 threats is so darn close to a top 10 list that I just had to flesh it out, and I've got a 10th threat that I've come up with that I think is a potentially really big one that we should all consider. Maybe not near term, but longer term. And I've added that in the end, and I've also made this into a top 10 format. So we're going to start with number 10, what the CSA considers kind of the least risky threat, and we're going to work our way all the way down to what I consider a potentially huge threat in the future as we go. People like top 10 lists? Yeah? Watch David Letterman? Yeah, drum roll. Okay, number 10. You want to say it out loud? No? Shared technology issues, exposed software. So remember, I didn't come up with these things, the CSA did. What does this mean? And this is what I was left with too. The CSA has interpretations in their document with some terse examples. And I thought, instead of just running with what their interpretation is, I'm going to go deeper than what they've done and talk about it and share with you the way that Microsoft looks at it, but also the way that customers look at it. So I think, hopefully, I can bring a unique perspective about how we look at some of these things rather than how an external user of public cloud computing would look at these things. And this is a great example because this one is one that keeps me up at night. What is it? If you look at a cloud, a public cloud, regardless of the vendor, is likely to be built on common software components. Of course, the cloud has programming interfaces. Well, actually, let me start at the bottom. They've got servers in their data centers. And for the most part, servers in a public cloud environment are homogeneous servers. They're unlike the way that most enterprises provision servers, which is, hey, let's go buy 20 of those from Dell. Let's go buy another 15 of these things from HP, so IBM, or now Lenovo servers. Let's go buy a bunch of those. Let's buy different sizes and forms. And in a public cloud, one of the keys to achieving scale and efficiency is homogeneity. So what we try to do is buy this massive amounts of the same server parts. And what that means is that there's massive amounts of the data center that have the exact same firmware and the exact same server parts underneath the whole infrastructure. We also have the shared hypervisor. Like I mentioned, we run Zen hypervisor. Crap. No, just kidding. We run Hyper-V. Wouldn't that be interesting? No, we run Hyper-V, of course. Amazon runs Zen. Google runs KVM. And so these are the hypervisors that are common across all our servers in our shared infrastructure. And then there's the web servers on top. So these are what expose the REST APIs for management and data planes. And guess what web server we're running in Azure? IIS, right? What, Apache? No. And then there's API support libraries that all that code relies on. And these are a lot of the Microsoft .NET libraries and the native code libraries that we ship to you guys to use too. The problem is, what if there's a vulnerability in one of these things that now it doesn't just apply to that unique little server in the corner, that's the one running that specific version of Hyper-V, but it touches all of those, all of the servers. And we can see the kinds of worries there that if there was a puncture, and somebody mentioned that as one of their threats that they were concerned about, a puncture in the hypervisor boundary, what would that mean to the public cloud? Or what about an open SSL flaw? Or a remote desktop exploit that could allow somebody to connect to RDP endpoint in your VM and inject code into it? Or one of our VMs that has RDP exposed for our management interfaces. Or here's another SSL is a popular source of these kinds of things. Everybody, of course, knows this, the most famous vulnerability logo in the world. I think maybe the only logo ever applied to a vulnerability. So I think we're going to see more of this. It's like the CNN, storm logos and other things. We're going to start seeing that for vulnerabilities as well. So the enterprise approach to these kinds of vulnerabilities, and I'm going to ask you if this is a correct representation of the way that you guys look at vulnerabilities. When you see a patch bulletin come out on Patch Tuesday, or for Microsoft software, or a bulletin come out from some other place for some other software you operate, and you go and you look at it and you say, that's interesting. Local elevation of privilege, potential vulnerability. There was one that was just fixed over the weekend in Linux that's been there for several years, like local elevation of privilege vulnerability. What do? Do you just say, turn on the alarms, blow out that patch to all your servers all at once and your workstations? Does anybody do that? Really? Nobody does that? You're all insecure? It's risk, right? Because you might actually do more damage than good when you do that. If you bring down your servers, it's what Mark Manassi was saying this morning, well, you can be secure and out of business. And secure means that the server's off because nobody can hack the server if it's not booting. So you balance risk against stability of your infrastructure. You also, part of your risk analysis is, are these surfaces exposed to the general public, to somebody that we don't trust? Or are these internal ones? How many of you operate terminal services someplace in your company? Now, if you look at most of the patches that come out on Patch Tuesday in Microsoft software, here's a list of recent ones. Win32k.sys, local elevation of privilege. Very common one. And do you, when you see one of these, rush and patch your terminal server systems? Probably not. And it's again the risk versus the risk of the security problem versus the risk of the stability problem. The fact is that anybody on your terminal server system using one of these things, if it's exploitable, and usually these things very often are, and not only that, but there's proof of concept code floating down the web within hours of these things coming out, they can take over, they can become admins on your terminal server system. And if they're admins, they can see all the data and act as any other user accessing that terminal server system. But still, you guys don't go, oh my God, another elevation of privileges. We need to go patch those terminal server systems within minutes to prevent that from happening. At least I don't. Does anybody do that? Operate and turn around that quickly and look at the risk like that? And the reason is because you know there's disincentives for your employees to be doing that kind of stuff. First of all, you've hired them, so presumably somebody's talked to them and made sure that they're not just, the kind of people that would just do this for fun. Second, you know that they know that you are monitoring what's going on in your system, so you probably have log files of who's accessed the RDP server. And so if something did happen, you could go back and look, okay, this guy logged in, that guy logged in, let's go and interview them. And if they start to act suspicious, let's bring in law enforcement. So you can get to the heart of the matter, and then you can either fire them or prosecute them. And this is what we call enterprise multi-tenancy. This way of operating and the trade-offs and the risk, the different risk profile for these vulnerabilities in shared code like that. Let's take a look at the way that we have to operate in the public cloud. A vulnerability in a hypervisor exposes the whole cloud. It allows somebody to get them a virtual machine, inject code into that virtual machine, take it over, puncture the hypervisor, and then compromise the other virtual machines on our infrastructure. So this is what the puncturing hypervisor boundary would look like. And those virtual machines there next to the attackers, they could be your virtual machine, they could be our own virtual machines that are operating our own infrastructure, or our cloud services themselves. And this is not just, okay, they've taken over your virtual machine. They have access to your data now that you're in your virtual machine. They have access to the data that those virtual machines are accessing too. If it's cloud storage, they have access to that. Or if those virtual machines are reaching back into your on-premises network, they have access to that too. And a single one of these incidents, if it's mishandled, could be doom. This is like one of those red button, those business is over in a day kind of scenarios that I think about. If this happened and it was exploited, and it was exploited in such a way that we had a hard time cleaning it up and even figuring out what happened, that could be the end of Azure. Now, that's an extreme example. There might be vulnerabilities that are exploited and not as catastrophic. Especially, part of trust is, are you doing as good a job as I would be able to do if I kept the data in-house? And so, if we're doing something that's just clueless, like the do as I say, not as I do kind of thing, then we'd be in trouble. Then you'd be like, what the hell are you guys doing? You're clowns, and I'm not putting my data in you. But if we're like, hey, we did all of these things, and you look at it and say, well, that's all of those things that I would have done too, then it's like, okay, crap happens, and occasionally there's screw-ups and things that are out of your control. But if we screw this up, that could be the end of it. And of course, we don't want people to even think that we're not doing the best we can do, because then they'll lose confidence in us. So the challenge for us, though, in something like this versus the enterprise world, is that the people that can do this to us are people that we can't identify. We have people that can sign up for trial accounts using a credit card and an SMS challenge sometimes, or a legitimate credit card or an SMS challenge, and then immediately start to use our cloud. So if there's a vulnerability, stolen credit card, boom, I've got some virtual machines, man, I've hacked the thing, who do we go in and prosecute? The deterrence there is just not there. These guys are above the law. Sometimes they're in countries we can't even reach, or countries that are like, whatever, when it comes to us trying to get them. And people are starting to realize this. This is an article just from a month ago. Hypervisors, the cloud's potential security Achilles heel. So this is the kind of nightmare scenario that I imagine. So a vulnerability in any public surface in the cloud can expose the data of other customers and cause them to lose trust in us. Here's one, and this one is a particularly interesting one because we faced this one last year. And this isn't an elevation of privilege, this is a denial of service. This is http.sys, the kernel mode web serving component in Windows. If you crafted a certain header and gave it to it, it would sit and consume the full CPU, and that would be the end of web serving off that server. Just a single malformed header. And we saw this thing, and because we're at Microsoft and we get told about these things sometimes from external finders, or we find these things ourselves, we're like looking at this and going, imagine if an attacker started to use this on us. What would we do in response? It'd be like damaging to our services, or damaging to your ability to access services, and it would apply to our entire surface area. It's not like we could just shut off some particular service and go, okay, we'll fix that, but meanwhile most of our cloud is up and running. This would apply to the whole thing. This is rated as an important bulletin, using our normal Microsoft Security Response Center bulletin rating system. What's important mean? It means not critical, right? Important means not unimportant, but it also means not critical. And what does critical mean? Wormable and data breach. It's a remote executable, remote code execution, RCEs. That's what criticals are reserved for. For denial of service, we just say, hey, that's an important. Your data is not at risk with this thing. But with the cloud, our business is at risk, and then you can't get access to your data. So we've come up with a new bug classification inside of Microsoft for our public cloud and our cloud services. We call it cloud critical. This is one that means our business could end if this thing is mishandled. And so when it comes to a cloud critical, We push these things out as fast as we can the second the patch is available to the public to minimize the window of exposure. So we're actually ready to go with our patches, with our deployment systems to press the button the second this thing goes live. Because the second it goes live, some hackers are reverse engineering that thing to figure out how they can use it. And if they realize what this can do and they say, you know what, I just want to have fun with Azure today, then we're exposed. We call this mode of operating hostile multi-tenancy, so that's where the term comes from in the title. It's different than enterprise multi-tenancy. Here, the risk of security problems far outweighs stability. And so we will go overboard to patch. And of course, we do everything we can to make sure that we stay stable, but we can't just afford to be like, oh, you know what, we'll make a fix and we'll roll it out over a few weeks to see how it goes, because all that time we're exposed to these kinds of problems. So the bottom line is that enterprises and the cloud are exposed to these kinds of shared risks. You're running the same HTTP.sys in your servers, for many of you. But we're at the higher risk of exploitation because of the reasons that I've described. We're a rich, juicy target if it comes to a data breach. Somebody goes, oh, you know what, I can use this thing. I don't have to go after a particular company. I can go after all of the companies hosted in some public cloud. So that makes us a bigger risk for something like this being thrown at us. Also, our API surface is trivial to access. A lot of you guys have a lot of your servers behind firewalls. So the public, anonymous users, anonymous attackers can't get access to it. They've got to work their way into your data center somehow, into your infrastructure, or it's got to be a malicious insider that wants to take advantage of this stuff. Lower risk of that than us having these endpoints like our HTTP.sys endpoints sitting out there for the whole world. We're saying, right here, talk to us right at this endpoint, and that's running HTTP.sys. Really easy for you to know because we're Microsoft and we make HTTP.sys and we're probably running that. But the inverse of this is that we're really probably a lot better at response than most enterprises. Because we in general are moving at this cloud cadence of pushing stuff out to the cloud, we've got deployment systems that are really good at patching. We have on the order of 1 million servers, as Mark mentioned this morning. In Azure, we can patch that thing if it's an emergency in under a few hours. The whole thing, the whole world, if it came to an emergency. Now, we wouldn't be able to honor kind of SLAs that we have where we're not going to take down all your VMs at the same time. But if it came to this, we'd be like, okay, we're going to blow the SLA while we try to get everybody secure as fast as we can. And that's because our business depends on it. So we also have breach mitigation and detection systems, monitoring activity from all our VMs, network activity from the VMs, looking for suspicious activities, looking for connections that shouldn't be happening, so that if somebody did breach something like that, we'd hopefully be able to detect it pretty quickly. This is the risk matrix. If you look at the Notorious 9 document, they've got a risk matrix for every one of these risks, and this is the picture of the screenshot of the risk matrix. This perceived risk is what they qualitatively judged the people that were responding to the surveys believed this risk level to be for this kind of threat. And then the vertical axis there is what they say is what CSA's opinion is the actual risk. This is one of the cases where I disagree with them. CSA's assessment is there, I believe, because maybe it's because I'm biased, because I'm looking at Microsoft and our cloud business and the threat to our cloud business in one of these things. This is where I'd put it. Of course, I can't move the perceived one because that comes from the survey results. But I'd put my assessment as far as the actual risk pretty high for Microsoft, which makes me really nervous about any exposure on our common substrate that we're running across our cloud. What do you guys think? Where do you think that the risk of this would be? Mine or CSA's? How many people think CSA's is actually more accurate? What do you think? How about mine? Good, right answer. Yeah. All right, let's talk about the next one. Anybody guess what the next threat is? Drum roll, number 9. Insufficient due diligence. What does that mean? Anybody guess what insufficient due diligence means? What's that? You know there was a fix, but you didn't put it in? I could see that being a relevant kind of definition for this, but that's not what the CSA uses for this. They use this as this rush to go use the cloud without really understanding the security risks of the cloud and how you should secure and manage data. And There's a term that the industry is being thrown around for this. It's called shadow IT. How many people have heard of shadow IT? How many people have heard of bring your own IT? BYOT. Yeah, that's the one I've came up with. Actually, you know what? I'm trying to start something. So if you saw me on, I think it was Channel 9, hashtag BYO, or the Garage Series, hashtag BYOIT, if you can spread that, because I think that's actually more representative here. This is, if you look at your end users, this whole BYOD thing is because your end users are bringing these devices into your net enterprise, and it's bring your own device. It's not wait for IT to give you the device. If you look at them consuming cloud services, they're not waiting for IT to deliver them the cloud services. They're going to get the cloud services from somebody else directly. So it's really like bringing their own IT into your enterprise. And the IT is somebody else. In the case of them using Azure, it's Microsoft IT, or the equivalent of IT that operate the cloud services. So that's why I think BYOT, and you can see that this is like a big meme. And the reason this is a big meme, of course, because central IT is designed for a slower pace. And that slower pace comes from the fact that you're provisioning softwares or servers and configuring networks using the more tools that are aimed at highly stable environments with business processes of ordering software, configuring the software. There's not self-service there, so you need people to fill that gap. At least many enterprises now, we're moving to more automated kind of private cloud environments. But the marketing department, when they want to run a campaign, if they go to central IT, it might be a month or 2 months before they get servers and virtual machines and network set up and DNS address, IP addresses that they can use and corporate approval for how they've configured the OS and everything. But when they can go to the cloud and say, I'm going to spin up some VMs and I got my marketing campaign online in a few hours, then they're like, oh, I'm just doing that. And that's bring your own IT. So the other part of this is that even when central IT is involved with moving the cloud, one of the questions, and I get this a lot, is like, how do I manage those VMs that are up in the cloud? I'm using System Center on premise. How can I manage my servers using System Center, my VMs in System Center? What about those PaaS VMs? How do I manage those things? How do I track credentials? Like I'm tracking passwords and making sure I've got password policies, but then there's passwords for these cloud services. How do I make sure that I've got the appropriate policies of rollover and complexity is set on those things? And you might not even be aware of all the places where there's something that you need to worry about when it comes to managing the cloud that you've been doing a certain way with certain tools and processes on premises. In fact, some of these places are just not filled in yet. Like, how do you manage? We just did this anti-malware as a service thing on Monday. We announced it. So you can get Microsoft anti-malware in your VMs in Azure, and that spits out to Windows Azure Storage, event logs. But how many of you have anti-malware event log analysis tools that know how to go read from Azure Storage? Probably not. I don't think they exist yet. But we need tools. We need those anti-malware analysis tools that are going and looking at what's going on in our networks to be able to go and analyze those event logs that are in that form in Azure Storage. So it's this immaturity of a lot of the tools and processes that are being built up now. And this is, I think, both a bane and an opportunity when it comes to the cloud. Because this is disruption, there's so much of this stuff that's new and yet to be filled in that there's a gold rush going on. If you look at all these antivirus companies like Symantec and Trend Micro, they're all like, let's get to the cloud and let's figure out how to solve this problem for everybody as fast as we can because there's money there for people that are there first to deliver these services. The bottom line is that everybody has to worry about this. This is like one of the key things. You cannot stand by and watch shadow IT go past you. Why? Because your job is to help secure your business, your customers. And if you sit there and let them go by you, they're putting your company's data at risk. And guess what's going to happen when there's a screw up with the data? They're not going to go blame the marketing department for doing that. Well, they might, but ultimately it's going to be like, hey, why didn't you guys help the marketing department get their marketing campaign up and do it in a reliable way for the company? So it's, as Mark Manassi would say, it's a resume-generating event at that point. When it comes to us, and I'm going to pepper through this talk some of the things that we have in Azure that you can look at to help mitigate further specifics, because I'm trying to keep this neutral just for all public clouds and considerations. But there's some things that we've got in Azure, like we've got this new service called API Discovery, which is you can take an endpoint, install it on your machines. Like a lot of people don't even know what your employees, how they're bypassing. What clouds are they using? Salesforce without you knowing it? Are they using Azure without you knowing it? Are they using Dropbox without you knowing it? So this is an endpoint, that a client that you can put on your systems, and it will monitor access to cloud services, and you can look up what's going on across your enterprise in a nice portal view and discover what's really going on. Of course, SDL, the secure development lifecycle, when it comes to making sure that there's due diligence on the things that we're doing in Azure, we've got SDL, and this is something that you guys can apply to look at all the threats. Like, what is the threat to this particular piece of data, this high-value data, and how should I secure it? It's part of SDL as well. Number 8. Somebody mentioned this one, denial of service. This is related to that, but this is abuse of cloud services. And this is a problem, a growing problem, because attackers, they see cloud services as a great opportunity for them too. They don't have to buy their own infrastructure, or, you know what, much easier to steal a botnet using stolen credit cards than to go and try to get end users to get infected with the botnet. Just get the stolen credit cards. Actually, you can get that from another botnet guy, and then go and set up these cloud services, and then you've got a botnet that can do things like denial of service. There's a few different ways that we see attackers using our cloud. One is as the malware platform, like I just mentioned. So bot masters, it's a great place to put a bot master. It's a great place to do denial of service attacks from. And so this is doing a denial of service attack against a particular customer. It's like they don't like you. Well, let me DOS you from Microsoft's IP addresses. Because now you blacklist some Microsoft IP addresses. And they're like, well, it's Microsoft's problem at that point. And also, your firewalls are like, oh, we trust Microsoft IP addresses, so you're going to let them in. By the way, this is an interesting observation I've had. You know how many countries now, in strict authoritarian regimes, they're blocking, using their national ISPs, things like Twitter and Facebook. Well, I'm afraid that one thing is going to happen here is that somebody's going to realize, instead of setting up Tor networks, which also can be blocked through those ISPs, is like, oh, let's go and use the cloud. Let's go and create virtual machines in Amazon or Azure, and then we'll do either traffic forwarding, or we'll actually have interactive sessions there to do Twitter and Facebook and the other things that these countries don't want us to do. I'm surprised we haven't heard anybody doing that, but that's kind of a more legitimate version of this malicious use of cloud services. Speaking of using Azure, or using cloud services for malicious activity, this is the top 10 ISPs hosting malware. This is from 2 months ago. A breakdown of the top ISPs in terms of hosting malware, doing denial of service attacks, serving spam. And do you see what's on there as number 1? That's AWS. AWS is the top server of malware on the web now, and it's because of EC2, AWS services, where these guys can hack in. Use of storage to distribute illegal content, that's another popular one. Put your child porn up in a public cloud. Makes it really hard for the law enforcement to go after it. They've got to go through other steps to go get at it. And here's one. This is a bold move by Pirate Bay. Anybody see this? They're like, instead of doing peer-to-peer or creating our own, going to our own colo facilities and hosting it where we can get shut down, let's just move to the cloud. So Pirate Bay, this is a distribution of illegal content. They're doing that too. And use of compute to mine digital currency. This one isn't so much a big deal for you guys, but it is for us. You know how many VMs we shut down? By the way, in total, VMs we shut down per month because of illegal activity? Take a guess. Well, 100,000 is the right ballpark. It's around 50 to 75,000 VMs we have to shut down a month. And guess what the bulk of them are doing? Now, they're doing all sorts of crazy stuff that I can't say on TV and in a recording. But the bulk of it is this. And it's not Bitcoin, because Bitcoin, it's pretty expensive to do on compute, and we don't have GPUs in Azure yet. But it's other cryptocurrencies that then they convert to Bitcoin. We analyzed this back in December, and we figured that with a stolen credit card, with the number of, in a trial account on Azure, which is about 200 hours of compute, these guys were generating $20 to $40 of Quark, a type of cryptocurrency. And then they were using Quark to go and convert that into Bitcoin, and then using it everywhere else. So this is a huge problem for us. And by the way, guess what countries are the top 3 countries that are using public cloud services for malicious activity? Number 1, China's not on the list. Russia, that's one. Number 2, no. I'm guessing you're probably not going to guess the next 2, although one of them is kind of obvious in retrospect. Nigeria. And then Vietnam is the 3rd. So those are the top 3 that we see. In fact, guess what the password is for the Vietnamese? The password is, no, actually it's, it's like MAUHTK123. And I might have gotten some of the letters wrong. But so we're like, what the hell is that? So we go and translate it on Bing Translate, of course. And you know what that stands for? Password 123 in Vietnamese. And here's an example. This is kind of funny. It's not public cloud computing, but Harvard had the supercomputer. At one point, it was doing supercomputer research, and then, people moved on to more powerful systems. So it was sitting there in a lab, massive supercomputer. People had kind of were lost track of what's going on there. And one day, somebody goes, "What the hell is that thing doing in there? This big electric bill." And they go look at it, and it's mining Bitcoin. Somebody had taken it over and was mining Bitcoin on the machines. Some attacker from outside. So this stuff is happening, and the problem with this is that, like I said before in the earlier one, these guys can remain anonymous. It's really easy for them to steal credit cards. We've got trial offers, too, where the credit cards don't even get charged. And we do a 1 penny kind of thing on them and then refund it. So it's not like the people that have their stolen credit cards, they don't even know that it's happened to them. It's not like they're losing money off it. So the bottom line is, from your perspective, this one's interesting because it's really our problem. It's really the public cloud provider's problem, not so much yours, except for the side effects of it. Because any one of those resources that the bad guys are stealing from us, we can't make money off of, and that hurts our bottom line, which drives up prices. And if it's happening to us, it's happening to Google and Amazon as well. So it drives up prices for everybody. This is just the same thing as credit card fraud, drives up prices for everybody. So there's some threshold, we want to pound this thing out of the system, and we're constantly getting better. These guys are getting better at evading us. So we've got all sorts of, we're actually using machine learning to look at the behavior, the network behavior of these virtual machines with weights on things like, is it a trial offer? Is it coming, or are there multiple trial offers with the same originating IP address coming into them? Are the same credit cards being used for multiple of these things? And so a bunch of things that we're doing to try to get better at fraud. We've got a team that is focused right now on fraud, the same team that is also focusing on internal detection of anomalies and breaches inside of our cloud infrastructure. Number 7, malicious insiders. Those really don't exist. This is more of a theoretical risk. Actually, it's not, unfortunately. And this one, we've got our own employees that have access to the cloud. We've got this new DevOps model. You talk to anybody else doing DevOps, like Netflix is one of the kings of DevOps. Their developers do a check-in, and minutes later, it's rolled out to Netflix worldwide. Well, what if that check-in's a malicious check-in? What if it's a backdoor? Or what if it's a DOS? What if it's delete data? I mean, that thing ends up rolling out to the whole world in minutes. That's great. That's efficiency. That's agile. That's agile, I guess. So we've got the developers, we've got the deployers, and they can deploy things. In theory, the operators are deploying code. What's worse is another threat is operations data center personnel. So one of these guys, let's say they go rogue and they're like, oh, I'm gonna steal stuff, and of course, here's the king of the insider threat right there. So we know that this isn't just theory, and these are different vectors into the system. So what do we do about this? What are the mitigations? And this is like, what can you guys do about our insider threats? There's not a whole lot you can do directly. But we, again, in our job of ensuring we got trust, do a bunch of things. One is we do background checks. Just like any company, we do background checks on employees, so we make sure that they don't have a criminal record. We make sure we look for telltale signs that they might be, have some grudge and they want to just join Microsoft so they can do something like this. But of course, we don't stop there. We don't trust them even at that point. We've got just-in-time access control systems. And this is best practices for anybody operating with the admin, is not to have standing admin permissions. How many people have admins that have constant standing admin in your network? And I should see probably every hand go up here, because even at Microsoft, we do have some of that, but this is a place where we're locking it down. So when it comes to admin access to production cloud services, we are like hardcore about no standing admin access. If you need access to production systems, it is just-in-time access. There's a workflow where you're granted limited as-needed access to just what you need to do to get your job done. It is audited. It's timed, meaning your access, your authorization, your privileges are removed after a certain amount of time, and then you'll have to re-authenticate. They're tied to workflows, like we use Team Foundation Server, for example, for incidents. And so there'll be an incident that says this person needs to access this particular service with these accesses to address this issue. And this is the timeout on it. And so that user goes to the just-in-time access portal. They register their need for this. Their privileges on their access to the system are elevated just for that time being. And then they get in and get the job done. So this kind of thing. And then, of course, we're monitoring and auditing to look for anomalous behavior so we can see if we can detect malicious activity or insider activity early. But the bottom line is that I can tell you that we do all these things, but from your perspective in assessing the risk of, like, who are these cloud guys, these guys managing our data, are they serious? You really can't take their word for it. You can't take my word for that we're doing it. Really, you want somebody that you trust that comes in and actually looks at what we're doing. Somebody that is like, okay, let's see that just-in-time access control portal that you've been talking about. Because I could just be making that up. And so they come in and they look at it and they see what the workflow is, and these correspond to certain controls that certifications have. And so that's what you're going to do, is look at controls. In fact, if you look now, here's a survey that just came out about a month ago, looking at different categories of cloud adopters in enterprise. From cloud beginners, the people that are just like, I've heard about this cloud thing, what the hell is it? To the guys that are like, we're all in, we're going to the cloud, man. No stopping us. We're going there as fast as we can. And then looked at what their various levels of concern across these things. And the interesting thing is security drops off. The more cloud ready, the more ready, the cloud committed the company is, the less of a concern security is, but compliance starts to go up. And so if you look, cloud-focused companies, compliance is the #1 concern. For cloud beginners, it's still security in this particular survey. And you can see, even for cloud beginners, it's compliance, because people know that, how do I know that these guys are really secure? Is that somebody else is telling me that they're doing the right thing. So here's the Azure perspective on this. We do employee background checks. We do just-in-time. And then you can see all the certifications that we've gotten for Azure. And this varies a little bit across our other cloud services. So it's for Office 365 and others, but Office 365 probably even has a longer list than this, but this is the common core here. And so you can see all of these. We've had auditors from the governments, auditors from the healthcare industry, auditors from all sorts of the payments control industry that come in and look at us and say, here are the set of controls, and you guys are actually doing all of these things that we've been telling you. So that's a way to mitigate risk from your perspective, is to, hey, do we have somebody that I trust saying that these guys aren't clowns? Let's talk about denial of service a little bit, because that's one somebody mentioned. The public cloud is public. That means that people can access it, and they can DOS our service endpoints. So like our control plane, somebody can come and say, massive, multi-hundred gigabit kind of DOS that we're seeing these days. People like the NTP vulnerability. That's this giant magnification attack, one of the largest DOSes in history, carried out using that vulnerability. You can see Amazon Web Services, DOS attacks, and articles about them being DOSed. In fact, this is just from a few years ago. They've gotten better about their DDoS, but they were brought down for a while by a DOS attack. And then your own applications, you put them in the cloud, and if they're sitting there public on a public IP address, then you're exposed to somebody DOSing you directly. And then, and you can see that's 204 gigabyte attacks. Then there's this other one, which is cloud outage. Cloud outage is a form of attack too. And this is one where something happens to our infrastructure. Power goes off. We've got a software bug that brings down the controller data planes. And now we've just DOSed you because you can't get access to your data or get your compute done. Here's one that hit both us and Amazon last year. Lightning storm in Dublin took out an Amazon data center and one of our data centers. So it caused what we call a brownout. It's like data center loses power. We've got redundant power to these from 2 different substations. We've got generators. We've got APCs. And despite that, this triggered bugs in the electrical infrastructure of both of our data centers that caused us to lose power to our servers when we never should have. And this is kind of fascinating to me because if you talk to our data center guys, these are 5 nines data centers. This means like seconds of downtime a year. And when one of these brownouts happens, the power to the server blips for a second or 2. And then the APCs don't kick on in time. There's some backward surge through the system, and something fails. But then the power is restored to the servers a second or 2 later. And so our data center guys are going, hey, we did our job. What's your problem? 5 nines. Meanwhile, the whole software system has to reset itself. The whole world has to reboot, and that takes like an hour or 2 to come back online. And so we're going, yeah, we're 5 nines data centers, but less than 5 nines of availability of that like you can still have a 5 nines data center and be like blipping the power to the servers every other day for a few seconds, for a second or 2. I guess the 5 nines is like 5 seconds of downtime a year or something. But imagine breaking that up into 10 half-second blips. So the power is going out every month almost, and we're rebooting the servers for 2 hours. And the data center guys are going, yep, within spec. That's awesome. And we're like, no. This is kind of the area where, when I look at this as a reliability engineer, when it comes to which would you rather have? Would you rather have 1 10-second outage or 10 1-second outages if they have that kind of impact? And so anyway, that's a little digression into the way I'm looking at data center reliability at Microsoft. Oh, and this is unrelated to this, but I love headlines like this. This is the register. This is a DOS because one of our APIs broke. And it was really not a massive DOS, but it affected some of our customers. And you can see that people like to talk about it. The press loves to talk about cloud outages, and the register is well known for creative headlines. So DOS is a significant threat. Some of the mitigations here. We protect against DOS. If you go look at our Trust Center, we've got DDoS. So we have we've had these third-party DDoS appliances that we stick on our data center routers and divert traffic. So when we detect DOS, we divert that traffic and black hole it on these things. We're moving to our own architecture now. We're investing heavily into taking control of our own DDoS mechanisms because we know that's such an integral part to having our service remain highly available. And when it comes to something like this is not one of those things where you want to be reliant on somebody else. It's like, well, this is really important. Let's take it over ourselves. Yeah, question? We do it for our clients as well. If we see somebody DOSing you, we'll black it off. Now, this is kind of large-scale DOS. If there's small-scale types of DOS or application-level DOS to you, that's something that we don't get involved with. But if it's one of those 200, 300 gigabit things that comes at us, we're going to black hole that. So one of the things that you can do is take your applications off the internet. If you have something, if you're using public cloud computing, but you don't need it to be on the internet, don't put it on the internet. And there's ways that you can still interact with it, and I'm going to talk about that in a second. And then there's also geoavailability. If somebody's DOSing a particular data center, if you've got a failover system, which you should have just to tolerate regional problems, or an outage of that region, fail over to the other one, and then recover from there. So for Azure, we have DDoS prevention systems. We have geo regions for failover. So every region we go into, we try to have 2 regions. Every geo, we have 2 regions that you can use as a failover partner for your deployments in one. So here's the perceived risk and actual risk. I think that from my perspective, the actual risk in Azure, and actually probably Amazon and Google does, is lower than what the Cloud Security Alliance has rated. So here's one where I differ. All right, number 5, insecure interfaces and APIs. The cloud's new. We're generating a lot of software, tons of new APIs. I mean, this is like a renaissance of computing, and so you see new services that you hadn't thought of before, sprouting up all the time, new protocols being created. And if you look at the Cloud Security Alliance, they've got another report where they say that the number of cloud vulnerability incidents by threat category, where threat category T2 there is insecure APIs, they say that this is one of the biggest risks to moving to the cloud in terms of these kinds of threat categories, as far as number of incidents. This report doesn't point back at the source data, so I don't know what those are. So I did some fishing on my own. So here's weak TLS crypto in one of our APIs. This is a storage API aimed at developers to be able to say, turn off SSL if you're using the local Azure Storage Simulator on your own dev box. No new reason to have SSL there. What we found is that developers would test with this setting, and then they'd push to their production system without flipping the setting to use SSL, and then they'd be sitting there talking to their storage over unencrypted traffic. Here's another one. It's a research report from Microsoft Research in conjunction with the Indiana University. Looked at a bunch of cloud APIs, specifically in the area of authentication, and found vulnerabilities in Facebook, Google, and others where there was incomplete verification of the headers. So somebody would do it was a three-party negotiation, and somebody's only validating the signature on part of the header, not all of it, and that allow an attacker to sit in the middle and manipulate data to get unauthorized access. So this one, yes, it's a risk, but some of the things that we do at Microsoft, I mentioned we follow SDL. You got to follow SDL. Use compiler tools, use threat modeling to go find these things. And customers, you guys, when it comes to APIs, if you're going to use cloud APIs, you should look at them too. If you're going to write software that uses those APIs, just look at those APIs and, you're responsible for making sure that you don't find those kinds of things as well. I mean, we're going to try to make sure we don't, but you should also know how you're using your APIs as well. Number 4, account or service traffic hijacking. And this one is somebody's gotten unauthorized access to your account, and they're using it as you. So some of the ways that people can get at your account. One is by getting your credentials somehow. One way is this Mordo worm, for example, that was spreading last year. This worm sits on the internet and does port scanning looking for RDP endpoints. And once it finds one, tries to brute force the endpoint to get in. This one is one that we actually see, when we were talking about abuse of cloud services. One of the ways that we see attackers using our VMs is to put worms like this in, trying to brute force the web and looking for vulnerable RDP endpoints. Weak passwords, of course, make it easier for them to get in, like that Vietnamese 123 thing. Also, stolen passwords. So this one is, we think, a stolen password from the target breach. The compromised password, in password reuse situations, all these massive data breaches that have the password databases posted to the web, and then they're either in plain text or they're easily reversible. And then you find out that somebody's been using the same password for Facebook or whatever the service was compromised as they are for their corporate login or a cloud service login. And so the attacker then is just like, oh, let me see if this thing works over in Amazon. Let me see if this thing works at Microsoft. And they end up getting into your systems with unauthorized access through password reuse. This isn't specific to the cloud, of course, but the cloud has this new vector, which is unmanaged credentials. If you look at many of these cloud services, they rely on each one on its own password or its own key to talk to the APIs or to talk to the control plane. And what that means is that your developers, when they're going and creating their applications, they're going and provisioning these accounts in these cloud services. They're getting back keys or passwords, and then what are they doing with them? Do you know? That's the answer that I thought you'd give me. You don't know. They're probably sticking, a lot of them, and believe it or not, we see, even at Microsoft, we see screwy things, hard coding them into their source code, putting them in an Excel spreadsheet, checking it into source control. Now, is that the way you manage your corporate credentials? It's like, no, you don't put them in file shares, you don't put them in Excel, you don't put them on SharePoint sites, you don't put them in source control. You manage them as like they're keys to the kingdom, because many times they are. So at Microsoft, we've got things called lockboxes or secret stores, where you need to be authorized to go pull a secret out, and it's encrypted, and you're authorized to get into it, and that's the way we manage credentials for our public cloud services. But this is going on as part of that shadow IT, and people not understanding that these things are floating around. Brute forcing, of course, and then, of course, through the back door here. So one of our developers gets phished, and they get access. That's another way in to do service account hijacking. Let's talk about the bottom line on this one. High perceived risk, high actual risk. This one is a real one. You lose credentials and somebody can act like you and get access to all your data or destroy your data. So mitigations here, turn off your unneeded endpoints. Use strong passwords, even better, use multi-factor authentication. The whole world is moving to multi-factor authentication. You can see it. It's a painful transition as we all do it because all our systems, I mean, you look at things like even Outlook, which is not really a multi-factor friendly type of application, and I'm sure you've got thousands of these things floating around your network, but we all have to move to multi-factor. And then breach detection, so you're detecting somebody's actually misusing you. For in Azure, we've got anti-malware, so this is to prevent the attackers from using common type of tools to, once they compromise your account. We've got IP ACLing, so you can make sure that only certain IP addresses can talk to your cloud endpoints, and they can only talk out to others, which is a great thing too. Outbound ACLs are great for stopping the attacker from leaking the data out to where they want to get it to. If they can only talk to you, then they can't get the data out to them. Point to site and site to site and express route, of course, these VPN tunnels, technologies that we've got in Azure for you connecting your on-premises environment to your cloud so you're not exposing those endpoints for attackers to get at. And then we've got multi-factor authentication where you can see all our stuff is getting enabled with MFA. Number 3, data loss. So there are multiple ways to lose data. One is that you accidentally delete your data. Another one is that an attacker deletes it or modifies it. This is a crypto locker piece of ransomware that was making the rounds, and you can see that it was aimed at consumers but actually infected businesses. Any business in here affected by a crypto type of malware? I saw a few hands go up back there. So this is one way you can lose your data, is like some attacker encrypts it, or that we accidentally delete it. And then natural disaster, of course, blows the data center away and all the disks that were there with your data on it. So how can you mitigate against this kind of problem? One is that realize that point-in-time backups still matter in the cloud. It's not like we're magically keeping point-in-time backups for your data so that if you delete it or some guy encrypts it, you can just say, oh, let me undo that. You need to make sure that you can undo that by taking steps to make backups. Also, for tolerating a geo problem, like I mentioned earlier, we have geo-redundant storage option in Azure, so you can synchronize asynchronously replicate or yourself take it in your own hands and synchronously replicate data between regions so that if one fails, you have the data in another one. And then we have deleted resource tombstoning. We learned the lesson the hard way when customers came to us, and we've actually made the mistake too of deleting subscriptions, customer subscriptions, and then the customers go, oh, where's my storage account with my storage data in it? And we don't know. What storage account? So that's not a good answer. So what we did is put in tombstoning. And this is something to consider when you write your own software. And try to make where you can delete not ever permanent. And so when a subscription gets deleted, we set aside those storage account resources for 90 days on your behalf. You don't pay for it. If you come to us 2 weeks later and go, oh, crap, you know what? I didn't mean to delete that storage account. It has like our financial stuff from last year. I need it really badly. I want it back. Then we'll re-enable that thing. We'll charge you for that time delta of the 2 weeks for the use of that storage, and then you can get back access to your data. And then we've also got this VM capture capability we announced about a month ago at Build, where you can snapshot your VM disks so that you have backups of complex VM topologies and the storage underneath them. And Azure Site Replica, so for DR, which Brad mentioned on Monday. Perceived risk and actual risk, pretty high for both of these. Obviously, we're getting down to number 1. And that's something that you definitely need to consider. And then number 2, data breaches. So this is a big one as we lead into number 1. And this one's kind of a complex one. Because what is a data breach? In fact, most of the things that we've talked about so far, these threats, are in some form aimed at data breaches. Because a data breach means somebody getting access to your data. If you look at these things like malicious insider, well, their threat really for malicious insiders, malicious insider getting access to my data. So let's break this down a little bit more and look at the different ways somebody can get access to your data in a data breach in a public cloud. And this is number 2, really, because this is the heart of the matter. What's the most important asset your company has, besides you? Is your data, is the data, company data. So let's take a look at the first one, physical attacks on media. How many people have been to a BitLocker session here at TechEd? So quite a few of you. You're aware of physical attacks because of physical access to the storage. The threat here is the attacker somehow gets hold of a disk with your data on it. So let's talk about how that looks in the public cloud. DC ops guy walks out of the data center with your disk. Could be inadvertent, could be intentional. Ends up on a truck, for example. That truck ends up, like somebody finds it, what the hell is this disk doing here? Well, I'm going to sell it on eBay, and it's got your stuff on it. People are concerned with that risk? Anybody? So let's talk about the mitigation here, because this is an area that we take very, very seriously to mitigate this risk down to close to zero probability of this really happening. And here's one example. To even get in the data center, we've got a gate. Yeah, this is actually pictures from our data center, one of our data centers. A gate, there's armed guards there in the booth. So you've got to be authorized to get past there. You can see fencing around the data center there. So it's not like, and there's cameras along the fences, so we can see people trying to mess around and get in the data center that way. Once you enter the data center lobby, you've got to prove that you've got authorization again to get into the data center and to be there. But not just that, if you want to go through the airlock to get into the colo area of the data center, you need to get authorization for that. Once you go in there, then to actually enter the room, because there's hallways at that point, to get in the room with the servers, you have to biometrically authenticate yourself. And that was authorized earlier at the lobby for you to actually enter the room. So only people with real legitimate reason to be in the data center to do some specific thing are actually allowed in. When it comes to the disks leaving the data center, we've got workflows that require anybody that's going to take a disk out of the data center has to have an ID for that disk from another work order that says this disk is being decommissioned or being sent back for servicing. Somebody's sitting there on the way out, making sure that the disk IDs matched what was already authorized to leave the data center. They're also making sure that it's gone through this process, so there's a certificate. We've got this data scrubbing or data destruction systems. In some cases, we destroy the media, like for SSDs. We don't allow that stuff to go out because it's really hard to scrub it. For HDDs, we'll scrub it before it goes out. And there's a certificate that somebody gets whenever they go through this that says this device actually went through the proper decommissioning or sanitization steps, and they've got to present that on their way out of the data center as well. And then we have, of course, these third-party controls that all of them, from FedRAMP to PCI to everything else, says if physical media leaves your control, it has to have gone through data sanitization or destruction processes that meet certain criteria. And you know that we've gotten all of those certifications that have those controls. So this is actually a very low risk, extremely low. I think it's effectively zero when it comes to data inadvertently or deliberately being leaked from our data centers. Now, there's a lot of companies out there that I see looking at this and saying, oh, who knows what's going on in their public cloud? We need to do encryption at rest. If there's no encryption at rest, then this thing is a wide open vector for somebody to get access to my data. In my opinion, encryption at rest, and there's two types of encryption at rest. There's one where we have the keys, and this is one that you see some other cloud vendors say, oh, we're going to encrypt your data for you. And there's one where you have the keys to encrypt the data. The one where the cloud provider has the keys is, questionable in terms of really the additional mitigation you're getting on top of this for a reason I'll talk about in a minute. The one where you've got the keys, well, are you ever giving the cloud the keys to do processing on that data? If you are, you're putting your keys in the cloud too. So, of course, the risk of the data and the key getting out through accidental means or deliberate means goes down even further, but still, it's theoretically possible. And it also, from an external, from a logical breach, which I'll talk about in a minute, it's still a risk. But one of the mitigations we also have in Azure is we've partnered with third parties to introduce encryption for VHDs, for example. There's companies like CipherCloud that let you encrypt data on the way into a cloud and decrypt it on the way out so that the keys, the data is never in the cloud. So those are some mitigations to consider if you really think this is still a big risk. Logical data breaches is another type. Well, actually, sorry, another physical one is man in the middle. And man in the middle, sniffing of traffic. Of course, this one made the news too, didn't it? This was a famous news article from a famous news article last year. Piece of paper napkin diagram that showed up at an NSA presentation, which says, hey, we're sniffing traffic on the links. This caused everybody a lot of consternation. Microsoft's official position on this is horrible. Google's, Facebook's, Apple's, everybody else, like this is a horrible, horrible thing. And actually, we are, as long as with everybody else we know, has made a promise to encrypt traffic, your traffic, when it travels between our data centers out of our control over lines that we don't control. We're going to encrypt it. And then we have TLS enabled on all our APIs, so if you want to talk securely to us, there's ways to do it with perfect forward secrecy. There's also, you can use your own TLS for your own applications. We recommend you get your own SSL endpoint certificates, and we make that easy for you. And our websites, for example, CipherCloud's an example of a way to mitigate it. And like I mentioned, we've got our public promise in Azure that we're going to be encrypting everything by the end of the year, interlinks. Side channel attacks, briefly talk about this. This is a threat. How many people are concerned with side channel attacks? VM sitting next to your VM, sniffing what you're doing. Has anybody heard of this type of attack? And how many people are concerned about this type of attack, just out of curiosity? So I just see a few hands going up. The CSA document, the guys in the CSA, they're like freaked out about this thing. If you look at it, there's side channel attacks mentioned throughout the whole document. In this attack, somebody sits in a VM, sniffing through caches or Hyper-V, symmetric multi-threading, looks at what's going on the processor and can somehow infer your secrets, your crypto keys, and reconstruct those keys in their VM sitting next to you. In fact, every few years, some researcher somewhere writes a paper where they, finally set up conditions. Look, we managed to get a VM here, and we were able to decode a key from another VM sitting right next to it. And when this happens, the press goes crazy and it's like, oh, that's the end of the cloud. Side channel attacks have ruined everything. But let me take a look at really the breakdown of this one. The researcher assumptions, their attacker knows exactly who they're trying to attack. Because obviously, if it's somebody that not of important, not interesting data, what's the point? They can co-locate on the same server. So like this is in terms of somebody attacking your data. They can co-locate on the same server. That's one of their assumptions. How realistic is that? Really unrealistic. In fact, there's cases where there's no way they can get a VM sitting next to your VM. One example is the server's full. There's no room for another VM. They just cannot. They can try to redeploy their VM all day long. 1 million deployments, they'll never end up on that same server because it's full. There are also the resource allocators, the VM placement algorithms, might bias against certain servers. Your VM is sitting over here, and the allocator never deploys to that. So they can deploy 1 million times, they'll always end up on these servers over here, never the one next to you. So the assumption that somehow they can target a server with your VM on it is a pretty far stretch. Then, once they're on there, they share the same core as you. They know what crypto library and what crypto key strength they're using, and they're not being interfered with. While they're watching you, there's no other VMs being time-sliced onto the same caches, and your own VM is sitting there only doing that, not doing anything else, which gives them enough fidelity to reconstruct the key. Because if you're actually using multiple keys, which you probably are in your VM as you talk to other SSL endpoints and doing crypto operations, then that blows their look at like, oh, which key was that, which key was that? So this, I think, is like security researchers gone wild, in my opinion, and going after a quick headline. But in practice, or at least right now, this is not a risk in any public cloud. All right, and finally, logical storage. The actor gains access to your data. How do they do that? Well, we talked earlier about the ways that they get access to your account is one way, or that they actually breach us and access through our logical APIs and are able to access your data through some other authentication, some other channel rather than your API. The way that we mitigate against this is we have defense in depth preventions, we've got monitoring and auditing, and this is a case, again, where encryption at rest isn't really the kind of silver bullet that people think it is. Let me tell you why. If somebody can breach the logical data, they can breach the logical service to get access to that storage account data, for example. What's the risk level of them not being able to also get access to the keys? And this goes back to what I was saying earlier about public cloud vendors encrypting data and rest at your behalf and them managing the keys. Because if somebody is able to breach them, get logical access to those keys, they get logical access to your data as well. And so that's not really a mitigation against a logical breach of the service. So, and this is an area where I see a lot of customers heading down in this direction. It's like, I'm going to manage the keys outside the cloud. I'll release them only into the cloud when I need to access the data. What kind of threat are you mitigating against then? Is it an attacker that gets access to your VM because they're going to see the key in the VM? Is it the government forcing somebody to give away your data? Well, if the government really wants it badly enough, the keys are there in the cloud. They can get access to those keys too. It's not like there's some magic technology that only lets your software use those keys but not let them have access to the unencrypted data that key's working over. So this is an area, I think, where there needs to be a little bit of more thought about why you're doing this. And I know that there's many cases in some industries which is just like encrypt at rest, just check that box. And it's really kind of not based on real threat modeling of the kinds of risks that you're mitigating against on top of what's already been mitigated by other means. So that's the bottom line is that I don't think media breach in at least the big three public clouds is a big risk because of all the physical controls we've got. I don't think encryption at rest really buys you that much other than a warm, fuzzy feeling. I think that network breach is definitely a risk because we've seen that in action, and the encryption on the wire is what we do and recommend. Logical breach is, of course, a risk, and we've got lots of measures to try to detect that and prevent it. But encryption at rest isn't like a big defense against a logical breach of data. This is where the Cloud Security Alliance puts it. High risk. I think, in my opinion, it's a little bit lower than that. And then, number one, self-awareness. The cloud becoming self-aware. I had to finish with one big risk, and you laugh. There are go search on the web for this. There are people that are like freaking out, can't sleep at night because they're afraid of us creating artificial intelligence and then losing control of it. And so we got to be careful as we go through this. And that's what keeps me up. I mean, Azure is just so awesome and so automated and self-healing that I'm afraid that one morning we'll wake up and Azure will say, "Good morning, Mark." All right, anyway, here's the top 10 list just to wrap up. I hope what you took away from this is a little bit of thinking about the different perspectives of the public cloud provider, what we're trying to do, as well as how you look at these risks and get past some of the hype and some of the checkbox mentality of, oh, we need to do this, and let's check the box, and now we're more secure. But really thinking about the different avenues into your data, the different avenues into the control plane, and how you can mitigate these risks. And the summary, this is new technology, so there are new risks. There are new implementation and design risks for all of this. It's all our joint responsibility, mine, doing talks like this, and others, to try to get everybody on board with understanding what's going on here. And it's not like, oh, that's too complex, don't worry about it. But really, let's take a look at the details of this and figure it out. And then, like I said, there's a gold rush here. As this is a new world and a lot of these things haven't been fully answered yet, lots of opportunity to innovate and create better ways to keep data secure. Like I mentioned in this morning's talk with Mark, one of the things that I'm thinking deeply about with other people at Microsoft, and especially Microsoft Research, is ways that you can give us your data such that we simply cannot access it. And you can do secure computations in the cloud in a way that somebody could come and say, you need to give us that data, and we can go, there's just theoretically no way that we can give it to you because of the systems we got in place to keep that computation secure from us. So with that, I hope that you found this useful and informative, and I hope that I didn't scare you away from the cloud, but actually encourage you to think about coming to the cloud in a responsible way for you and your customer. And want to ask you to fill out an evaluation, give me your feedback on this. If this is a worthwhile talk you think to keep doing as this technology and the space advances, please let me know. And of course, one last thing, little mini commercial. I'm doing a book rogue code signing, a second one tomorrow at noon, because I ran out of time today to sign everybody's books. So if you want to pick that up. And I'm doing sysinternals malware hunting tomorrow morning and finishing up with Case of the Unexplained. I hope to see you all there for a fun session tomorrow afternoon, and hope you have a great rest of Tech Ed. See you tomorrow. And to analyzing them. And then let's talk about mitigations that you might be able to put into play, or we put into play, to mitigate those kinds of risks. That's the goal of this talk. I'm not going to be doing any demos. It's a very kind of different talk than you might have seen me do, or you're going to see me do tomorrow, which is a down, dirty Windows internals kind of thing. This is a high level, let's get thinking and talking about the architecture of public cloud computing and the threats. And to set this up, one of this is a very disruptive phase. Brad showed a slide like this, and this is redundant with that, but I've given this talk before internally at Microsoft. I've also gave it at RSA conference, a version of this. And this is obviously the third phase of computing that we're moving into, and whenever it comes to a new phase of computing, a new way of operating computers and managing data, there's questions, there's unknowns. We're all learning. In fact, we're learning. I'm still learning about how to best secure our systems in this particular aspect. And so it's obvious that there's going to be questions. It's natural that there's going to be questions, and we all have to work through this together, and we're going to come up with some new answers as we go along, too. So I'll wrap that back around to the end. The problem here is that, like I've mentioned, the public cloud is built on trust, and security is a key part of trust, and if we screw that up, that's potentially the end of Microsoft's public cloud computing business, or at least a major setback for Microsoft and maybe the entire industry. I think one of the interesting things I saw was that Microsoft and Azure had cloud outages of reasonable size a few years ago, and the press and the public, the technical public, kind of the market, reacted to those things by saying, oh, looks like public cloud computing isn't ready yet. And people start to think, maybe I should back off and wait till this thing becomes a little more mature. So that's why this is so important. And when it comes to considerations for moving to the cloud, security is not the only reason that customers say, I'm hesitant, or I need to take my time, I need to understand things better before I move to the cloud. But security is definitely one of the key considerations. There's study after study that comes out which says, interviewing CIOs and saying, hey, looks like the cloud's coming, what do you think? Are you ready to move to the cloud? And you can see that time after time they come back and say, well, the cloud looks interesting, we're looking at it, but security is really something that worries me. In fact, here are some of the other things that they worry about. And you can see in this survey from 451 Research back in December of 2012, they rated these various different considerations on a scale of high concern, medium concern, low concern, and you can see, for example, immature technology. Is the cloud immature? Well, some people are concerned that it might be a little immature. And then you can see all the way down to compliance. People are concerned about compliance because of their own businesses. And back in 2010, and they wrote a report called 7 Top Threats to Public Cloud Security. And then they realized, you know what, we missed a couple. So then they wrote a paper called about 9 top threats. They called this the Notorious 9. Has anybody heard of the Notorious 9? So you can go download this as a free download off of the CSA website. It's a PDF. It's actually a pretty terse document, but it does document the 9 threats that they organized as a result of these surveys. And that's what I'm going to go through. Now, the 9 threats is so darn close to a top 10 list that I just had to flesh it out, and I've got a 10th threat that I've come up with that I think is a potentially really big one that we should all consider. Maybe not near term, but longer term. And I've added that in the end, and I've also made this into a top 10 format. So we're going to start with number 10, what the CSA considers kind of the least risky threat, and we're going to work our way all the way down to what I consider a potentially huge threat in the future as we go. People like top 10 lists? Yeah? Watch David Letterman? Yeah, drum roll. Okay, number 10. You want to say it out loud? No? Shared technology issues, exposed software. So remember, I didn't come up with these things, the CSA did. What does this mean? And this is what I was left with too. The CSA has interpretations in their document with some terse examples. And I thought, instead of just running with what their interpretation is, I'm going to go deeper than what they've done and talk about it, and share with you the way that Microsoft looks at it, but also the way that customers look at it. So I think hopefully I can bring a unique perspective about how we look at some of these things rather than how an external user of public cloud computing would look at these things. And this is a great example because this one is one that keeps me up at night. What is it? If you look at a cloud, a public cloud, regardless of the vendor, is likely to be built on common software components. Of course, the cloud has programming interfaces. Well, actually, let me start at the bottom. They've got servers in their data centers. And for the most part, servers in a public cloud environment are homogeneous servers. They're unlike the way that most enterprises provision servers, which is, hey, let's go buy 20 of those from Dell. Let's go buy another 15 of these things from HP, so IBM or now Lenovo servers. Let's go buy a bunch of those. Let's buy different sizes and forms. And in a public cloud, one of the keys to achieving scale and efficiency is homogeneity. So what we try to do is buy this massive amounts of the same server parts. And what that means is that there's massive amounts of the data center that have the exact same firmware and the exact same server parts underneath the whole infrastructure. We also have the shared hypervisor. Afternoon, everybody. Are you the only guys that care about public cloud security in the whole place? That's cool. Welcome. My name is Russinovich. I'm a technical fellow in Azure. I've been in Azure for about 4 years. And my primary job responsibility is to look at the compute stack from the very bottom, our data center infrastructure, all the way up to our cloud programming model. But as many of you know, I've got a strong interest in cybersecurity, and I have from way back before I joined Azure. And so one of my roles in Azure is also looking at security and cybersecurity of the cloud, thinking about how customers can stay secure and how we can secure customers. And also, I think from me, a very high priority is how we can make sure that our infrastructure is the most secure infrastructure. Because there's one thing about public cloud computing that is very important for Microsoft and any other public cloud provider to keep in mind, and that is there is no cloud without trust. Because we're asking you, customers, to put your data under our control, into our data centers, onto our servers, under our operational management. And that is an enormous responsibility. And you're only going to do that if you trust that we're going to handle it properly, that we're going to make it available to you when you need to access it, that we're going to prevent other people from having access to it. If we screw that up, we can lose your trust, and that means that we can lose the whole business. It's not like you've bought a piece of software from us and you're off and running it and you lose trust in us, but you continue to leverage those services. For this kind of business, we've got to keep and maintain that trust going forward, and security is one of the key pillars of the trust. The other ones, of course, being availability and reliability. So this talk is a talk that I put together because as I've been talking to customers and as I've been talking to even people inside of Microsoft and Azure, a lot of misconceptions around what it means to be secure in the public cloud. A lot of misconceptions about, oh, the cloud is somehow less secure than on-premises environments, or somehow it's a huge risk for me to go and put my stuff in a public cloud because of who knows what's going to happen there. So the purpose of this talk is to dispel some of the myths around it, to get you thinking about how you play a part as you move your data and manage your users accessing the cloud, that it's not just our responsibility, it's not just your responsibility, it's a joint responsibility to secure this data. And then also to talk about some of the risks that we hear you tell us, what you're thinking, CIOs, why they are afraid of moving to the cloud, what makes them hesitant to move to the cloud. Talk about really what is behind those risks. Let's take a look a little bit deeper. Accessing consumer services that are built on the public cloud. And again, these kinds of services aren't just Microsoft services, but anybody building services here. So if you have an enterprise, for example, you build a line of business app, consumers are going to be going and accessing that line of business app that's running in a public cloud. And then, of course, we've got these guys, which we all hate, of course, the people that are out to screw everybody over, but we've got to deal with them, and these are the attackers. The guys that want into the data, the guys that want to bring down the data center, and they do it for as we know, many, many reasons, from political motivation to, hey, it's just cool and I'm impressing my friends on ICQ, to whatever. It's a political nation thing, or actually I'm going to steal the data and then sell it. Now, when it came to the threats, me sitting down to talk about this, of course, I have in mind what I consider some threats to cloud security. But I thought, I'm just one person, and really it's you guys, the CIOs, CXOs, the IT administrators, the ones making decisions about what you move to the cloud when, that are really the ones that are the ones defining threats, what you consider threats. What's an example threat that you imagine when it comes to public cloud in security domain? A threat to your data. What would be a threat to your data? Anybody? No threats? Yeah, one. Foreign nation states, like what is the threat there? Okay, so this is exposure of your data to somebody that you don't want to have access to your data. This is nation state being able to say, hey, I want access to that data. For some reason, you're from Europe, aren't you? Yeah. So this is, I could guess that. That's a big concern there. Anybody else? Any other threat to data in the public cloud? To your data or compute? Denial of service. That's another one. Yeah, another one? So diverting traffic to someplace else, that's a potential threat. I'll take one more and then virus penetrating the hypervisor security boundary. That's a good one right there. These are all examples of threats that I've also thought about. But instead of just coming up with my own list, I thought it would be interesting to refer to the Cloud Security Alliance. Anybody familiar with the Cloud Security Alliance? So a few people. The Cloud Security Alliance is an organization made up of representatives from a bunch of different companies, including Microsoft, that obviously focuses on cloud security. And one of the things they do is periodically survey their members, as well as CIOs, business decision makers at companies, and say, what are you concerned about when it comes to security in the public cloud? They first started this and regulations that they've got to operate under, but what I blacked out here is that the number one by far with high concern is security, 69%. How many of you are concerned security moving to the cloud as your number one concern for moving to the cloud? Okay, so let's work together on figuring out what's real, what's not real, and what you can do about it, and what you should be really worried about versus not worried about. So we're going to identify the threats, discuss the risk of each of the threats that people talk about when it comes to security in public cloud, and then we're going to explore some of the mitigations to figure out how we can reduce risk from the levels they might be at, things you can do and things that we're doing. To kind of frame the discussion and make things a little more concrete rather than hand-waving and saying, oh, data loss, that's a threat, is to really talk about what does data loss mean? How can you lose data in a public cloud? I've set up a canonical reference architecture, and it looks like this, that we're going to use various points throughout the presentation to try to make these things a little more real. So first of all, you've got the public cloud infrastructure itself. So this is the public cloud, and you can see that the public cloud consists of a few different components. One is the interfaces that are the public interfaces. These are the management interfaces and the data plane interfaces for customers to go create virtual machines, create email subscription, email accounts, to create mailboxes, to deploy virtual machines and code into those virtual machines, and to access data in the public cloud. Of course, underneath those APIs is actually a virtualized infrastructure. So most public clouds rely on virtualization as a key part of their security and multi-tenancy. Azure is fully virtualized. So you see virtual machines there with hypervisors underneath them, of course, Hyper-V. And then you see storage servers there, and then at the bottom you see racks of servers and disks. You see a DC operations person. So this is in our giant data centers. You have a few people running around maintaining the data center facility. Then you also have us, Microsoft, the people that are developing the software and operating the software. In this new DevOps world, we've got developers that are pushing code into production and then sometimes debugging code in production. And so some of the teams at Microsoft have separate deployment engineers that are actually responsible for pushing the code that the developers create. So that's represented there. And this part of the infrastructure is operating on the same technologies that your on-premises networks are. This is built on Active Directory, Windows on our desktops, Windows servers, on our domain controllers, the same kind of infrastructures. We're talking through private networks into our data center. So this isn't going over public IP addresses. This is through Microsoft internal backbone that goes into our data centers for us to push code into there. And then finally, we've got, of course, the customers of the cloud, and these include the enterprises. They include consumers that are